Hello everyone. So in this video we're going to talk about feature scaling and specifically normalization. We saw about scaling in the previous one. We saw standard scaler and various scalars in Scikit-learn. So let us begin. So the agenda for this video is we'll see the prerequisites, introduction, then we'll see the norms in sklearn and documentation and a sample code. So the prerequisites, as usual, we have Python, statistics because you should know certain formulas for the normalization, and even if you don't know, we'll discuss it briefly in this, and NumPy and pandas. So introduction. So the process of scaling individual samples to have unit norm is normalization, and the minimum and the maximum value of features are used for scaling. So what normalization does is it scales the value between 0 to 1 or -1 to 1. Okay. Both normalizing and scaling can be applied on rows as well as columns. So usually they're applied on columns, but if you want, they can also be applied on a row. So for example, let's say if you want to use the max norm, there's a type of norm that Scikit-learn offers, which is max norm, where you basically divide each and every element by the maximum of that specific, either row or column. Depends upon how you are using this, which will usually be a column. So if you're using the max norm, then you'll directly divide each and every value with the maximum of that specific column, let's say. And normalizing is sensitive to outliers. Now this happens because let's say if you have some values, so most of the values are around, let's say 1, 5, 10, or 1 to 10, and they spread out in between, and due to some error, we've seen about outliers that they can happen due to various reasons. Now let's say in this case, due to some reason we have an outlier which has a value of around 100, or let's say 200, probably even 1000. So in this case, now when you're normalizing that specific feature, the maximum, when you're using the max norm, the maximum value will be this specific outlier, which is 100 or 1000 or anything that has been a result of the error. So when we are normalizing using this, each and every value will be very less, and then the outlier will be the value 1. So if you think about it, let's say if there is the number 1, so 1 will become, let's say, 1 upon 100, that is 0.01. Similarly 10 will become 0.1, and when you have all such values in between 0.01 and 0.1, and then suddenly you have a value 1, so you can see how drastically the data has been affected. So we'll see about it later, about how normalizing changes the geometric shape of the data, and we basically now know that it is sensitive to outliers. So normalizing is very useful when we do not know about the distribution, and of course you have to use pre-processing and remove the outliers or handle the outliers first, and after that, if you do not know about the distribution, then normalizing is something that you should go to. Now, normalizing changes the geometrical shape of the data to a bell curve. We saw in the previous video that the geometric shape remains the same in terms of scaling, but for normalizing, it changes it to a bell curve because it is just limiting the values to 0 to 1 or -1 to 1. So when it is limiting, this is how it will look. So it is changing the shape. Like if this was the original data, then this is how the new data will look. And this sort of curve, is called as a bell curve. So that's why it's said as it changes the shape to a bell curve. Now we'll see the different norms in Scikit-learn. So Scikit-learn provides three norms. The first one is max. So what max norm does is it basically divides each and every value from that row with the maximum. So it uses the absolute maximum and works similar to the max app scaler, which we saw in the previous video. So yes, it uses the absolute maximum, and its formula is pretty simple. X normalized equals to x upon a maximum of absolute of x actually. So over here there's a you know, a little bit different in the formula, and that was about max norm. So about L1. So what this does is it uses the sum of all values. It takes the absolute of all values and then sums it and gives equal penalty to all the parameters. So this enforces sparsity. Now the formula is pretty simple again. X normalized equals to x upon sum of x, or sum of absolute of x rather. And then the third norm we have is L2. So L2 uses the square root of the sum of all the squared values. Now it might be a bit difficult to comprehend because of the words that are being used to understand the formula, but once we see it on the whiteboard you'll be pretty clear with it, and this creates smoothness and rotational invariance. So L2 is also known as spatial sign preprocessing. Now the formula here is x normalized equals to x divided by square root of sum of square of each and every I value. Now that might again create a bit confusion, but to remove that we'll actually see the whiteboard. So we have the whiteboard over here, and for example if this is our data, we have 3 rows like you can see. Now if you want to use max normalization, so let's say max norm, then so first we'll remove the maximum values from each row. For the first row we have 2, for the second row we have 4. Even if this would have been -4, we still would have taken 4 as the maximum value. And then third row we have 1. So now these are the maximum values from each and every row. Now we're going to divide each and every entry with these maximum values of the corresponding row. So for the first row we are going to divide each and every entry with 2. That is 1 upon 2 becomes 0.5. Again -1 upon 2 becomes -0.5, and 2 upon 2 becomes 1. So this is how the first row will look like after we use the max norm. The second row will look something like this: 4, 0.25 and 0.5, which is nothing but these values divided by 4. 4 upon 4 is 1, 1 upon 4 is 0.25, and 2 upon 4 is 0.5. So similarly for the third row will look as it is because we are dividing it by 1. So anything divided by 1 is the number itself. So that is why there won't be any change. And this is how our normalized data will look like if you're using the max norm. Now if you're using L1, so this was max. I've note down the formulas over here. This is for L1 and this is for L2. So now if for the same data, if you're using L1, now for L1 what we were taking is we're dividing it by the summation of x. Now x is each and every entry for every row. So for the first row, 1 plus 1 plus 2. Now note that we are taking the absolute value of x and not just x. So you're going to take the absolute value. Again over here, absolute value. So when you're taking the absolute value, 1 will stay 1 as it is, -1 becomes +1. So 1 plus 1 plus 2, that gives us 4. So I'll just write it down here so that it's easy to calculate later. For the second row, the summation of absolute values becomes 7, 4 plus 1 plus 2. And for the third row, it is 2. So this is the array that we'll be using to apply L1 norm on this data. So for the first row, 1 divided by 4, you'll get 0.25, -1 divided by 4, minus 0.25, and 2 divided by 4, you'll get 0.5. So that was for the first row. And for the second row, we're going to divide it by 7. So 4 divided by 7 will give you somewhere 0.57 or so, and 1 divided by 7 will give you 0.14 something. Again, 2 divided by 7 will give you 0.28, and it will go on. So I'm just writing rough figures over here. So this is what it should look like for the second row after normalizing. And for the third row, we just have to divide all these values by 2. So 0 divided by 2 remains the same, 0. 1 divided by 2 becomes 0.5. Minus 1 divided by 2 will be minus 0.5. So this is how your data will look on using L1 norm. Now for L2 norm, which is a bit trickier than these two, but it is still pretty simple if you once understand it. Now for L2 norm, what we are going to do is we are going to first square each and every value from the row and then do the summation of it. So for the first row, it is 1 square plus 1 square plus 1 square. So that will give us 1 plus 1 plus 4, which is 6. Now we have to find the square root of 6. So the square root of 6 will get approximately as 2.44. So 2.44. So that will be the first value. And for second one, you have to take 4 square, which is 16, plus 1 plus 2 square, which is 4. So you have to take root 21. So root 21 is approximately 4.5 or so. And next, 0 square plus 1 square plus 1 square will give you 2 directly. So now we are going to divide each and every row values with the corresponding row values from this. Now 1 divided by 2.44. So that will approximately give you 0.4 or something. Again, minus 1 divided by 2.44 will give you minus 0.4, and 2 divided by 0.44 will give us 2 divided by 2.44. So 2 divided by 2.44 will give us around 0.8. Now similarly, 4 divided by 4.5, so that should give us 0.8. Then we have 1 divided by 4.5, should give us somewhat like 0.2, and again 2 divided by 4.5, so that will give us 0.4. And the next one is again easy, 0, 0.5 and minus 0.5. So when you cut it down into steps, it is pretty easy to understand, because what you're doing is you're basically first taking the square of each and every element of every row. So over here we took 1 square plus minus 1 square plus 2 square, so that gives us 1 plus 1 plus 4, so that gives us 6. And then what you have to do is you have to take the square root. We took the square root of 6, which gives us approximately 2.44. Similarly, for the second row, you're squaring and summation, square and summation, and then square root. So that's all it is doing. And once you get those values, you can note them down, so it is easy for you. And all you have to do is divide each and every value from a row to the corresponding value in that corresponding row. So that was it, and these were the norms in Scikit-learn, and we'll also see a code, but before that I think we have to see the documentation. Yes, we'll see the documentation for this. So this is the Scikit-learn official website, like we have seen many times before in all of the videos. And I've just opened the pre-processing module, in which if you see at 6.3.3 there is normalization. Just click on that and you will see everything about normalization that Scikit-learn library has to offer. So firstly, normalization is the process of scaling individual samples to have unit norm. We saw that in our presentation, and it is helpful for us if you can plan to use a quadratic form such as dot product, etc. So there's a lot of things about normalization that you can get to know over here. Then how to normalize using this library. So it's as simple as pre-processing.normalize, or if you're importing normalize, then you can directly write normalize. So that is how it will be done in scikit-learn library. And if you want to see an alternative by using the transformer API, then this is how it's done. So you'll use the normalizer and dot fit again. Okay, dot fit does nothing over here, so without fitting you can just transform it directly. So okay, L2 normalization is also known as spatial sign pre-processing. Once again we saw that in the presentation. So yes, that's all about normalization in the official documentation. So which is why we'll see our code once again. We'll see into the code how we can just change this to L1 and how the result is coming out. So I think we have coding next. Yes, we'll now move on to the sample code. So we'll continue in this document itself for the pre-processing module. And okay, so we'll see all the three types of norms. We'll see their sample code, and we'll also see how we can, do use that norm without the scikit-learn library. So basically like an alternative, and just write norms as a comment. Okay, this is the text. Okay, so I can just write normalization, and then we can start with the code. So first what we'll do is we'll just take a sample data set, or rather define a sample data set, and we'll actually use the same one which we saw for on the whiteboard, so we can also understand if what we calculated was correct. So I had taken 1, -1 and 2, then we had 4, 1 and 2, and then we had 0, 1 and -1. So that's how our data looked like on the whiteboard, I guess. So let's just run it so that it's connected on the Google Colab server. And now we'll just begin with the code. So from sklearn.preprocessing, we'll import normalize, and of course we'll import pandas as pd, and we'll import the math function because we require square root. So import math. So now our max norm. So how will max norm be calculated? So let's say x underscore norm equals to normalize, and you just take the data set, you've stored it in capital X, so x, and you just have to define norm equals to max. So this norm feature has three values, which is max, L1 and L2, and just print this, print x underscore norm. So there you go. We also calculated this on our whiteboard and it was the same value. So that was just basically the two lines which we need to normalize in scikit-learn. And once again, like I said, it is done row wise. Now we'll also see how max norm is done without using scikit-learn. So just write without sklearn, and we'll first change our x is an array over here. We'll change it to data frame. So pd dot data frame data equals to x. Now we have to take a variable. So while calculating on the whiteboard, we first calculated all the maximum values and wrote it down. Similarly, we'll first do that here. We'll get the maximum value from each and every row and we'll print it, and then later on we'll divide it, we'll divide all the elements of that row using these. So norm max, let's say, equals to, we'll take it as a list. We need maximum value, the list of it for all the rows, and we're going to need absolute value of I. So now we have to define what I is. So for I in df dot iloc r. So iloc is used to access the individual elements in a data frame. So now again we have to define r over here. For r in range length of x. So length of x over here is just 3, and for basically what this code is doing is it is listing out the maximum value, or it is getting the maximum value and storing it in a list. And maximum value, again we have to take absolute before finding the maximum. So this inner for loop is going to traverse through all the elements in a row, and this outer for loop is going to take us to each and every row. So that is what it is doing. I'll just print it so that we can see. Norm underscore max. So it is giving us 2, 4 and 1. So the first row has 2 as maximum, second has 4, third one has 1. So it is correct. Now what you have to do is we are going to just normalize the data using this. So we can use a similar formula over here by just tweaking it a bit and modifying some of it. So norm of data equals to, let's say, list, and now we do not need max because we already have the max value, and we just have to take again list, and this time we are directly going to take I, but we have to divide it by the respective value of the maximum of that row. So norm max, and which one? Now norm max has 3 values, so we need the first one. So I'm going to take the value r. So now again we have to define r for, okay, so before we define r we have to define I, right? So for I in df dot iloc r, and outside this we have to define for r in range length of x. So I think that ought to do it, and we'll just print this norm underscore data. Right, so you can see, and it is showing in one line because we are taking it as a list. If you want it to show as an array, you can just do np.array, and that will do the trick. Okay, we haven't imported, so we'll just, okay, I'll just take it over here itself. So import numpy as np. So there it is showing it exactly like our scikit-learn output, and it is same, so you need not worry. Now for L1, so L1 norm. So by using scikit-learn, again it was pretty easy. Let's just take x underscore norm equals to normalize x comma norm equals to L1. So that's all it is, and again we'll do print x underscore norm. So like you see, we again calculated this as well, and it's matching our answer. So this is how L1 norm is done, and it's just a one-liner code. If you exclude the import, we have already imported normalize, so we do not have to import it again. And now similarly we'll see without sklearn. So for this again, what we can do is we can write similar, but again we'll have to make certain modifications because earlier we are taking max, now we just have to take the sum. So if I just uh, copy this, and instead of max I write sum, I think that should do it. So it is giving us 4, 7 and 2, which is again correct because for L1, if you remember the formula, it uses the sum of absolute values. So over here 1 plus 1 plus 2 will give us 4, over here 7, and over here 2. So absolute value, so negative value becomes positive for this, and yes, it's correct. Now again, to get it over here, so yes, now we just divide our data using this. Actually I can change this name, but it's fine. So after dividing, you can see that what scikit-learn function gave us as the output, it's the same over here, and that was again without scikit-learn. Now we'll see the last one, which is L2 norm. So using scikit-learn again, it is as easy as x underscore norm equals to normalize x. So by default, I think it'll take L2 to print x underscore norm. So by default it's taking L2, even if you do not mention, or if you want to mention just to be sure, you can take norm equals to L2 and you'll get the same data. Right. Now we also saw an alternative in the sklearn documentation, so we can also try that out. So I just write alternative, and so for that we'll have to import from sklearn.preprocessing. We'll have to import the normalizer, and yes, let's say normalizer equals to normalizer. So we're calling the instance of the class, and now we'll just print normalizer dot transform x. So it will transform x and directly print it out. So again, it's the same result as this, and what was mentioned was of course correct. It is supposed to be. And now we'll see the example without using the scikit-learn library. So for this, okay, without sklearn, I'll just write the comment again. Now we can use what can we use? So I think we can use sum over here, and we'll have to change this a bit, or yes, I'll just copy this. So now in this, what we have to change is we can remove the absolute value because square of negative value itself becomes positive, so we need not take absolute, it's not necessary. Even if you do, it is fine. And now for this, let's change the name so it's not confusing. Norm L2, let's say norm L2. Now we have list and sum. Okay, so we have to take sum of I square, and after taking the sum we have to take the square root. So I'll write math.sqrt. So this bracket is ending here, and so I think this should do it. Right, so we again, after calculating the value by which each and every element should be divided, we wrote it down, and we approximately got these only 2.4, 4.5 and 1.4. So now again, to print it out, to actually normalize and basically to divide each and every element, we'll write the code. So it'll be similar to this. We just have to change it a bit. Over here, let's take data, we'll print data. So now we have already, we don't need square root, we don't need sum, we don't even need I square. All you have to do is divide it by norm underscore L2 and R. So the extra brackets won't be a problem. And okay, again it's showing as a list. Just for it to show properly, I just write nb.array. So now it is printing as an array, and this is what it is. And approximately we did calculate this, and I think we are correct. So this was all about the norms in scikit-learn library. And just a recap, there are three norms, which is max, L1 and L2. And we saw all of them. We saw them on whiteboard. We calculated it by ourselves, and then we also saw it in the code, and with scikit-learn and without scikit-learn as well. So let us go back to the presentation. I think that's all we have, but let's just check. Yes, so that's all from this video. I hope everything was clear, and we saw what normalization in scikit-learn is, and basically what normalization is and the formulas. We checked it on whiteboard, and then we applied it into our coding using scikit-learn and also without scikit-learn. So that's it once again, and thank you for watching. I'll see you in the next video.